Hello everyone, welcome to Fantastic Solution. So today we'll be solving a Leetcode medium problem named as max area of island. So this question is an extension of the question named as number of islands, which we have solved it. I'll add the video into the description. You can go through that, and we'll try to solve using the similar approach. So here, what it says, you are given an m cross n binary matrix grid. So here we have given an input of m cross n binary matrix grid, and an island is a group of ones. So one is basically it's representing the land connected in all the four direction, horizontal, vertical. So let's say if we are at any particular place, so if this is a one, so this is a land, and this can be like connected island can be in any of the four directions. You may assume all four edges of the grid are surrounded by waters. So outside, if we are going this particular grid, so everything is water. So that means even this particular one is also a grid for us. Sorry, island for us. So the moment we encounter any one inside this particular grid, so that would be an island for us. So that's basically what this means. Now, what's the requirement? Requirement is the area of an island is the number of cells with a value in the island. So if you're at particular, if you're going to find the area of this particular island, so the area would be 1, 2, 3, 4, 5. For this island, it would be 1. So here it is 5. Here we have 4. Here we have 2, 3, 4. And for this particular place, we have 1, 2, 3, 4, 5, 6. And for this particular place, we have 5, right? So it says return the maximum area of an island in the grid. If there is no land, then return the 0. So we need to return the maximum area of the island. Otherwise, if there is no maximum area, if everything is water, we can return 0. So for this particular use case, if you see here, we had this 1, this is 4, this is 5, 4, 6, and 5, right? So that's why the maximum area of the island, is 6 here. That we can think of. And that's why you can see it's been highlighted into a different color as well. So that's how that's what about this particular question. And let's see how we can go ahead and solve this. So the solution would be exactly similar for this particular number of island problem. This is an extension of that. So we'll try to solve using the same approach. So let's see what are the options we have right here. So let's say if you're finding any island here, so we need to know the area of the island. So anytime if you're finding any one or land, right? So we need to go and explore all the connected lands for that particular one. If at particular, let's say if I'm at this particular place, if I reading the grade from one by one, and if I came here, if we find any land here, so our goal should be to go ahead and explore all the land in all the directions, and then the moment we found any one or any land, just go ahead and increase the counter to find the area. So let's say if we are trying to find the area of this particular grid, so what should be our approach? So approach should be the moment we find any one, right? So now we know that we have found an island, so that means the minimum area would be the one for us, right? So now just go ahead and explore in all the four directions, right? So the first thing like our function should explore in all the direction. So that's the very first thing we'll do. So let's say if you're going up, we found a 0, then return 0. The moment if you're encountering any 0, so we need to return false, right? We don't need to we can just return 0 from there, or return false, whatever you can think of. So if the condition is 0, or like if we found any at any place 0, we can just return 0, because we are not going to include that. Similarly, if I found 0 at any place, we can just return it back. If in any direction we found it 1, then what do we need to do? We need to go ahead and then if you find any 1, then add in our area. Like just go ahead and add in area. That means increase your area by 1, and then again go ahead and explore in all the four directions. So if I came here, I just go ahead and extend my area by +1, which is 2. and then go ahead and again explore in all the directions, uh, in all the four directions. So now if you see the left hand side is 0, so we can return the false directly. If you go down 1, then we will just go increase the area of counter by 1. So that means that should be increased by 1, and then it will go ahead and explore in all the directions. So from here, let's say again if we came, we'll be going and exploring all the directions. So from the left and the down will be returning 0. From the right, what will happen? From the right, if you see, this is a new thing. So again, we found a 1. We will just go, add or increase the area by 1 again, and then explore in all the directions uh, from the backward as well. So here and here we found 0, which will return back to us. From here, if you see, we found a 1, and then just go ahead and add +1 as well. So the total area will be 1, 2, 3, 4, 5. The total area currently came the 5, and it will just go ahead and explore in all the directions, right? Previous as well. So here we got a 0, which we are going to return the 0 from here. But if you see, we have already, if from here, if you're going to go back into this direction again, the left hand side, we have already explored that. So if we have already explored something, then again go ahead and return 0. So from this particular cell, we can't go left. Then backtrack, came back again, right? Then go back again, and then go back again, and then just return it. So anytime if we are finding any 0, then return 0, or if the area has been already explored, then also return 0. But what if you're at the boundary location, right? So the let's say if you're at this particular cell, the right or left, if you encountered 0, we can just return 0. Bottom, if you encountered any 1, increase the count of area by +1 and explore in all the other direction. But what if you're going outside the boundary, right? From here, then again just go ahead and the fourth condition should be outside boundary, right? Outside boundary, then again return 0. So these are the condition. If you're able to handle it, then we are just going to find the area of any island. And the moment we are finding, so our goal should be find all the area, and then whatever the maximum area is there, just keep it there for your use case. So that's what we are just going to solve it. And in the previous question, if we had encountered that, so what we're doing for the explode path, right? If we don't, let's say, if I have come from this particular cell to this particular cell, I don't want to go back, right? So we need to know whether we have explored this particular cell or not. That's the identification we need. So in the previous question, what we had done, we were for the explode cell, what we're doing, we're changing our existing grid only, like we're marking with the 0, right? So for this particular cell, all current question, let's do a different approach. Like let's say if in certain cases, it's not allowed in interview to change the original grid, right? So in that reason, what we can do for explore area, we can create our own 2D grid, and there we can add the marking and all. I'll just show you how we can do into the program, so that if you go through the both programs, the both approaches as well. So that should be our end goal at any particular place. Let's just go ahead and try to write our program. So the very first thing which we said, we need to have our own 2D grid or to explore this, whether to mark whether we have explored certain grid or certain cell or not, right? So let's just go ahead and create some cell here. Oh, sorry, 2D grid here. So it should be let visited uh, array is equals to new array of grid.length. And let's go ahead, since this is a 2D grid input, we need to initialize as a 2D array here. And let's just mark with the false, initialize with the false every cell here. So let's I equals to 0. I should be less than visited array.length I plus plus. And then visited array of I. For each particular cell, initialize a new array of length grid of I dot length. Okay, and now just let's fill this with false. So now we know that the visited array, what does it mean? So this visited array would be exactly similar to the input grid. And false means the currently we have not visited any of the cell of this particular given input grid. So that's what we have done as of now. We haven't done anything much in the as a program wise, but we have like defined our 2D grid, which will be use to mark any particular cell whether we have visited any cell or not. So that's the initial approach for us. And now let's go ahead and explode this grid and try to write the DFS function as well. So let's I equals to 0. I should be grid dot length I plus plus, or let j equals to 0. J should be less than grid of I dot length comma j plus plus. And what would be the condition? The condition would be the moment we find any one in this particular grid, we know that that would be a land for us. At any particular place, we find any one, right? So we know that that would be a land for us, right? So if grid of I comma j, or grid of I is j equals to 1, we can write, or even the grid of I j is also fine, right? And we need to find the maximum area. So let's define some max area variable here, which is 0. And anytime if we are finding any land here, then our goal should be to update our max area. So max area would be math dot max area, and then what we are going to do, we are going to write some DFS function and pass the I comma j. What it will do, let's say if it found this very first this grid cell from here, right? It will just go ahead, and we are expecting that this DFS function will return for this particular case 5. The output, it will return the 5. So our DFS function will always return the area of this any particular island. So that's why what we are doing, we are checking whatever the area we got from this particular DFS function for any particular the island, and whatever the maximum area currently we do have, whatever the max is there, we can just do it. But one more thing, the moment we encountered one, right, then we shouldn't always go ahead and explore this DFS function. We should also know that uh, whether we have already visited that particular cell or not. That also we should be aware of that. So the condition should be if grid of I comma j equals to 1, and we have not visited this particular cell as well. So visited array of I comma j should be false, right? So if you haven't visited this particular cell, then only just go ahead and find the maximum area. If you have already visited that particular cell, then there is no point to go ahead and explore or check direction, because that means if at any point we have visited any particular island, then we have already encountered or find the area of that, and we have added it here. So there is no point just going again and checking in that the infinite loop. So now let's go ahead and write our DFS function as well, which is taking the indices of that particular cell. So what would be the false condition, right? Or base case false condition for us. So we have written that if we encountered 0, then return 0. Or if you're going outside the boundary, then return 0. Or if it's already explored, right, then return 0. There are 3 criteria for that. So if you're going outside the boundary, right, from here to here, then return 0. Or let's say even if it were from here to down, right, or at any particular cell outside, we don't want to go, right? So just go ahead and write that condition. If I is less than 0, or I is greater than equals to grid dot length, or j is less than 0, or j is greater than equals to grid of I dot length. So what we have covered as of now, we have covered this, going outside of the boundary. So this criteria we have already done. If you're going outside the boundary, then our goal is just return 0. Second criteria is if we find any 0 as well, right? So the current cell is, if it's already 0, right, then there is no point to explore as well now further. So we can add that condition as well, right? Grid of I j, the current cell, if it's equals to 0, then also return 0. So that means we have also done this particular condition as well for us, second condition. Third is basically, if that particular cell has already been explored, then just go, don't explore it. So let's say if we have already come to this particular cell, if you're already here, right? uh, and we have come from this particular cell, then we are going to explore in all the four directions, but there is no point to go back and explore here as well because we have already come from here. So we need to, be like add a check for that as well. So if so what we are going to do currently, if it's the cell has already been visited, we are going to use our 2D array or 2D grid, which will be marked as a true or false, if it's already visited. So visited array of ij. So if current cell has already been visited, then also we can just go ahead and return 0. If that's not the case, then that means, uh, at what particular cell we are there, it's definitely a 1 and we have not visited this. So if you're coming at this particular line, then that's for sure means, this particular whatever the cell we are there, it's a 1 and it's also not visited. So what we are going to do, if it's a 1 and it's not visited, then we are just going to first, add it into our area and then explore in all the four directions. So these are the two things we need to do, like add our area and explore in all the four directions. As well as I forgot to write this. If it's a 1, then, mark as well that we have already visited it. Mark visited. So the moment we encountered some 1 which we have not, if it's a 1 and not visited, then mark it's a visited, right? Add into our area. So this particular whatever the 1 you're finding, add into our area, and then move ahead in all that four direction to explore any other one, something like that. That should be our goal. So let's just go ahead, since we have already got a 1. So now mark or visited, array of this particular cell that, hey, we have now, visited this particular one, this particular cell, and then add the area, like +1. So what should be the area? Let's say, or directly what we can do, we can explore in all the direction. I will just show how can we add the +1 as well. So explore in all the directions. And add them. So I+1, I-1, then I comma j+1, and should be j-1. So our goal should be, just go ahead and explore in all the four directions. And if we found any one, add them, and then add +1 to that. So that should be the thing. Like, so if we have already found a 1 here, just go ahead, if we find any 1, and add +1 to our existing, the area as well. So that's what we did. If that's the case, we should be able to find the maximum area, and then at the end of this for loop, we just need to return the maximum area. Now let's go ahead and run this. Let's see if there is not visited. What is that? Line number 14, what do we have? Here we should add the OR condition. Cool. Now just go ahead and submit this. Yeah, so it's already been submitted, accepted, and if you see it beats 33% problem. One extra check, if we want, we can add it here. So if grid of I or grid dot length equals to 0, then, you can just go ahead and return false. And now let's go ahead and submit it. So that will, kind of improve our performance for that. Similar to, what we have added here. Okay, grid is null as well, the condition, extra condition. Yeah. So now it's splitting, now we got the better performance now. So add, if the grid is null or grid dot length is 0, then we're returning zeros. There is no need to, do other checks. So that's a edge check, which is going to improve the performance for when we have the many test cases scenario. So that's it about this problem.